All right, so I guess we'll just jump right into things here. Our first presenter today is Dr. Rainer Lohmann, professor at the University of Rhode Island's Graduate School of Oceanography. Has a degree in chemical engineering and a doctorate in environmental science. He's the director of the URI-led Superfund Research Program Center on the Sources, Transport, Exposure, and Effects of PFAS, otherwise known as STEEP. His research focuses on the detection, fate, and transport of anthropogenic pollutants in the environment, often relying on passive samplers in the process. Dr. Lohmann.
Good afternoon, everybody. I'm sure you're just as happy as me to be here for the last session. So let's make it worth our while. I gave a preview of this a day ago, so I don't have to go through some of the first slides that you've seen already. And I was trying to spin an arc of a story, and I wasn't sure where I was going to end, but at least we know where I started. So let's skip this, and we know what PFASs are. And so I think what I was trying to say is that we have, on the books, at least thousands of PFASs. The numbers differ. I think industry says a few hundreds have been produced. Typical monitoring targets, a few dozens. And right now, EPA so far is only targeting 2. And clearly, there's an imbalance. The question is, what do you do about this? And there's different ways with which you can do that. And one of the challenges is that we realize that the target compounds alone are not sufficient anymore to explain what we find, for example, in human serum. And that's the bars in black here. And that's a timeline from the 80s down to 2010. And you see that the black seems to be increasing. And depending on the year and the number of Germans sampled here, it's between 10 and 40%. So we have a large fraction that we don't actually know what it is. And then, of course, what do you do about it? And one option is to just say PFAS are a class, and several of the co-authors of this paper, I think, are in this room. And that would be the idea, to just treat them all as one class and phase them out. So far, that hasn't really been pursued that aggressively by regulatory agencies anywhere in the world. So maybe that option will work, maybe it will not. Of course, the second paradigm is what EPA is currently to do, is typically doing, is regulating one component at a time. And that clearly, given the scope, is probably not that viable either. All right, EPA has focused now on, I think, 26 subgroups and tries to identify each a representative chemical and then test all of those, but that's still a heck of a lot of chemicals to test. So, and then the other question is if we can find something that helps us figure out whether we need to have PFAS. And this slide I shamelessly stole from Green Science and Policy Institute. These are all consumer products, and in all of these cases, PFAS were used or are still used in giving the properties that we might desire in these products. All right, one is a firefighting foam. I guess that's not a consumer product, really. And so either way you go, then the big surprise question is whether we can say this has been linked to, is it really essential to have PFAS in that use? And not a big surprise, that's what I'm going to focus on for the rest. And Jamie DeWitt is in this, and she'll recognize some of the slides because I shamelessly just copied them from an earlier presentation we did. So don't be surprised if it looks really nice. It wasn't my take. So Ian Cousins led this work with the Global PFAS Science Panel. Mark is on that, Jamie, and a lot of others that are in this room, or not in this room. And the idea was to bring up this essential use idea. And it wasn't anything new. It was already put forward by the Montreal Protocol. And for those of you who are a little younger than me, that was put in place as a UN agreement to phase out ozone depleting compounds. And they put a very high bar on essentiality, and it was essential use is something necessary for the health or safety or the functioning of society. So we don't want a revolution because of it. And it also is something where there's no available technical, economically feasible alternative. So it does stress economically feasible. So maybe a quick view back. And again, this is actually one of the few good news stories from the Earth system. So NASA scientists, I think it was NASA, identified there was a problem in the ozone layer above the Antarctic. Early on, the instrument triggered there was a problem, and they always thought the instruments were wrong. And only years later, in the 80s, I believe, finally they realized that the instruments were always right, and there was an ozone hole. And so then eventually, every country on Earth ratified this agreement, which means actually the US too, which is unusual because most international protocols are not ratified by the US. And the idea was to do something about that ozone hole, which was threatening us and livelihood on the planet. And the good thing is the ozone hole has been shrinking and shrinking. In a decade or so, it's basically a thing of the past. But what happened is it wasn't a straight ban on every single compound that was a problem, which were initially with CFCs. But it was a progression, and this was actually not regrettable, but actually wished for substitution, because every substitution was a little better than the previous one. And then eventually you end up, so CFCs were replaced by HCFCs, so they put a hydrogen, so they were less, or they would break down faster. And then eventually now we had HFCs, and there's actually even a roadmap. And the outcome was that the use dropped fairly quickly, but not on all uses. And so this is where the essentiality came into place. So most consumer products were phased out very quickly, but things like where it was used for coolants and where it was fire concerns about replacements, that would be just alkanes, the substitutions took a little longer. So that was kind of the roadmap for PFASs. And you can see how now eventually we phase out basically almost everything that would deplete the ozone layer. And later considerations for the Montreal Protocol actually include greenhouse gas potential. They've become more integrative or holistic in their assessment of what is needed. Anyhow, so on the side of PFASs, non-essential, all of those that are non-essential, not a big surprise, which means alternatives exist already. Obvious ones are cosmetics, ski waxes, no matter what. Everything that you can buy, you have a product that has PFAS, another one that does not. Of course, we as consumers can't tell which one is which, but that's a different story. But basically, you can just say, get rid of it, no harm done, we can move on. 2 is substitutable, which means that PFAS do confer an essential property, but there is alternatives on the market that can be used. Great example now, of course, AFFF, because most, on almost all instances, non-fluorinated firefighting foam can be used and is used across Europe in the DoD. So things is done. And then, of course, it remains essential, particular medical devices, protective clothing, and probably a range of industrial applications that we don't even know what they are. And so when we published this paper, we came up with a few categories. And so we put in random numbers between 1 and 3, 1 being can get rid of the PFAS straight away, and 3 you can't, and 2 probably. And if we didn't know, we just put an or in. And basically, almost all consumer products can put in a 1, because really there is nothing that is that essential. It gets more difficult with, there are some specific firefighting foam uses. I believe they're on aircraft carriers, but maybe Mark will actually know. Oh, submarines. Yeah, you don't want to have a fire on a submarine. All right, so there are some specific exemptions right now where the 3 or 5 second difference of extinguishing might play a role. I think for now, when we did the list, anything medical would say, yeah, let's make that a 3 for now. That's probably essential. But the idea was always essentiality is a concept that should have a sunset date and R&D attached to it, right? Just the same with AFFF. It's not as if alternatives were just there, but when there was a need considered, then suddenly R&D stepped up and we have the alternatives now. So we went through this list and then basically, Jamie, one of your pretty pictures. So as we now know through some of the high profile publications, PFAS show up in a range of cosmetics. They probably confer possibly some advantage, but it's really nothing that is essential. Others exist, can phase them out straight away. The breathable membranes where Teflon is involved, Gore-Tex-like stuff, clearly they have big advantages, and they don't seem to work for me, or maybe I'm too sweaty, but their alternatives exist. You can have stain repellency, water repellence through other means, so you can substitute. You can go ahead, and of course, now you already have high-end retailers or manufacturers that do sell those PFAS-free items. And it takes a little bit of finding them, but they exist. Certain brands have those, so that's easy. And category 3, right now, we put the example of the Turnout Gear, which of course is tricky because firefighters would love to get something else. But for now, that's the state of the art. You need certain PFAS in the firefighting Turnout Gear. And the other part linked to, of course, the PFAS is the problem that they have a life before they're produced and they have a life after. And both of those are not well understood. Well, we understand the waste side, which is a big mess. The production side, some of the communities next to production place have something to say about that. So we thought the Essentiality can help regulators, purchasing agents for states, towns, federal agencies, doesn't really matter, even those within companies that make products. Keen Shoes is a good example. They've gone through their entire supply chain and figured out they had, I think, over 100 PFAS containing products, and they basically phased them all because they didn't really need them. But it took them a lot of time. But you can use this essentially. Do we need it? Can we put something else in? What's the outcome? So what's the status? It depends. Of course, some things have been phased out very quickly because either of consumer pressure or because of legislation or because manufacturers basically said we don't want PFAS on our carpets because it might give us a bad reputation. The authorization bill has phased out AFFF basically for the DoD. So there's different ways. And of course, there's litigation that might also help tip the balance. So things are moving forward, and PFAS Central has a list of PFAS-free products for those that are interested. And has this idea caught on? To some degree, yes. So in the EU, the European Commission has published the Chemical Strategy for Sustainability. And there is the direct reference to phasing out the use of PFAS unless their use is essential. So the idea has caught on. Whether it gets traction and how it's implemented is a whole different story. As was mentioned, Maine has Maine has called them, what's the word? They don't use essential, they use unavoidable uses of PFAS are going to be phased out by 2030. So they are trying to do something now. Maine is a pretty small player. If it was California, it would probably have a little more, but that's a different story. I don't want to, it's no problem being small. I'm from Rhode Island. And we know California has taken up some of this in their discussion or in their interrogation of what chemicals can be phased out of consumer products too, but it's on a smaller scale than Maine. And with that, I want to thank you for your attention, our funding, and if there's questions, that would be after everybody has spoken. Perfect. So no questions for me, please. Thank you.
Okay, our next speaker is Commander Mark Miller of the U.S. Navy. He's in the U.S. Public Health Service. He serves as the Director of Scientific Management for the National Institute of Environmental Health Sciences, NIEHS, the division of the National Toxicology Program. As part of the senior management team, he provides scientific leadership and collaborates to build integrated research teams to advance the Institute's mission. He serves as a subject matter expert on PFAS, persistent organic pollutants, and endocrine disrupting chemicals. He earned a PhD in toxicology at the University of Michigan School of Public Health.
Thank you. I'll just start by saying I am not in the Navy. The U.S. Public Health Service likes to think that the Navy has borrowed our uniform. Because we're a very small force and with only about 6,000 officers under the U.S. Surgeon General. And so just a small piece there. And I will also say that this is not advancing.
It's down at the bottom.
On the bottom left.
Left, if you scroll over.
Okay.
The buttons are not working.
I think if you just click on the white part of the screen, it'll activate the show, and then you can just use the arrow keys.
Okay. We should be good now?
Yeah.
Good.
Okay.
Thank you so much. And I'll also say that these are only my opinions. These aren't the NIEHS, the NIH, the Department of Health and Human Services. And so this is me speaking as a scientist. Very quickly, we'll thank you, Rainer, for your introduction for defining essentiality and what is essential. We'll talk just briefly about that for how we can apply that into a framework, and then talk about what some of those challenges have been. It's very nice, for you sitting here as an academic in your ivory tower to be able to say that essentiality is something that is achievable. But many of the folks in this room are really working in the real world, and they need a better framework to understand how this applies to their applications. And so I'll talk through a framework that hopefully gives you a little bit of insight into how you might be able to do that. And then talk through some of the challenges. This work has been out for a number of years now, and there have been challenges to it that help us to think through how it can be applied in a more feasible, more realistic way. And I think that's only strengthened the essentiality construct. And so going through what some of those are, and perhaps even in the question and answer session, getting more input is only going to help us more fully develop that thought. So here's a little cartoon that really gets to the heart of that question of what is essentiality and how do we define essential. And here we have the one gentleman saying, do you mean that the ropes are essential or the PFAS in the climbing rope is essential? And why that's actually a really good example to use in this cartoon is because there may be some benefits to having PFAS in your climbing ropes. It prevents water from saturating the rope, making the rope heavier, which makes it more difficult to climb. There is an advantage to doing that. But is that advantage essential is the question that's really being asked. And so going to what we just saw on the left side of the screen, you can see that there are two elements for essentiality: the necessary for health, safety, and the functioning of society, as well as the question of whether or not there's technologically and economically feasible alternatives. And this is just to remind you of what we saw a moment ago in the categorization that was provided in the Cousin et al. Paper. So in building a framework to actually apply this to use cases, what we want to do, and why I've blocked out the upper three colored areas, is really think about the decision that needs to be made. That should really be driving all of the other considerations that you'll see in this framework. And one of the questions that was first asked is who should be using the essentiality framework to be able to make decisions. And I've listed a bunch of folks on the bottom of the screen. We obviously go to regulators and governments as a group that should be thinking about essentiality for chemicals of concern, but we also have the manufacturers, the material scientists who are designing them into new products. We have the folks, consumers and retailers and commerce. For retailers, we've seen a couple great talks about retailers that are phasing things out. We've seen talks about how consumers are driving purchasing decisions that will influence retailers' decision-making. And then we also have NGOs, we have advocacy groups. They can also support this effort by thinking through this essentiality construct for where they might want to put their efforts and energies in order to get the most impact, particularly toward that endpoint of public health. So in doing that, we need to go through and look and really in a framework to evaluate essentiality for a use case, we need a few definitions at the beginning to really more tightly define what it is we're evaluating. And the first is, what is the specific chemical or group of chemicals being evaluated? Notice that doesn't have PFAS written into it. The essentiality construct that we just heard about started with, ozone depleting chemicals, and it can be applied in many different areas. Obviously today we're thinking mostly about PFASs and those use cases, but clearly it can be used in a lot of different areas. And so clearly defining which group of chemicals? Is it PFAS very generally and using some of those multi-thousand definitions? Or is it specific PFASs within a product that you are defining as your chemical of interest? You know, I know the EU has a very specific definition of chemicals of concern. And that's what we need here before you start looking at an essentiality assessment. And why is so that you can take that and look at what is the actual technical function of that chemical within the product or process that's being evaluated. And notice you can do this for both products and processes. So it's not just the actual deliverable product or consumer good that you're purchasing, but rather the process of making those can also be evaluated for whether or not that PFAS is essential in order to create that good. And then you need one additional definition. And this one's probably, I'll talk later on in the presentation about, is probably the hardest to define. And what is that service that that product or process is providing? Because that's really where we're going to need to start to determine whether or not the chemical is essential. Because until we've defined what that service is, we won't really know whether or not that chemical could even be possibly considered essential. And where we see that is if in fact the service that's being provided is not necessarily for health, safety, or the functioning of society, then the use of that chemical cannot then be essential. There's a good paper from Joel Tickner's group that really talks about this in greater detail, and I'll give you the reference a little bit later on. But keep in mind that it's really, is it delivering a service that is essential for health, safety, and functioning of society? That's going to be that first bar with no other information, if no other information is available. We then need to look at whether or not the use of that chemical within that product is actually providing that service that has been, if it is deemed that the service is essential. And so in looking at it, you may have PFAS in a product that is deemed essential. Maybe for functioning of society, we deem the cell phone is essential. And if we're looking at it, there may be some applications within that cell phone where PFASs are necessary, coating chips, those sorts of things may or may not be. We need to look at those individually, but perhaps the case doesn't need to have the same consideration of essentiality based on the service that's provided by the particular chemical. And then finally, we need to look at whether there are alternatives available for that technical function. And this also gets into Molly's talk earlier about alternatives assessment and the way in which that can be done in a very thoughtful way. And so, although these are listed in this order, if you have information that you can get to there is an alternative already available, you may not need to do the full assessment of service, of technical function, because you know that there's already a PFAS-free alternative out there that could be used. And if something has risen to the level of a chemical of concern for whichever decision-making group is making that, wanting to go through this essentiality construct, then we know that there's an alternative out there. Perhaps we don't need to put the time, effort, and energy into every particular chemical and use case that's being considered. And so now there's been a lot of questions of how to apply this. And so with this as a general framework for how to think about the essentiality concept, I'm going to go through some of what those questions and concerns that we've heard as part of this might be. And one is it appropriate to group? And I would say that it's almost necessary to group. because we also understand that because chemicals can't be evaluated for their essentiality, only a chemical use case can be. What we've done is actually almost compounded the problem. We now have so many more situations where you're looking at, if we were using an EPA chemical by chemical approach, now you're looking at it chemical by chemical and use case by use case. And so you would potentially be multiplying the number of situations that you would need to evaluate. But what this allows us to do is very easily group many of the chemicals, because the use cases can be very easily determined to be necessary for health, safety, or the functioning of society or not. And then perhaps it wouldn't matter which PFAS or potential breakdown products of those PFASs would be used in that application. And in addition, we would be able to look at multiple chemicals even within a given use case. And so it wouldn't necessarily make a difference which bike chain lubricant PFAS was being used if it's determined that that bike chain is not necessarily an essential function for society. And so defining which a group of chemicals you're going to use is very important, but it also creates a challenge because we do have the OECD definition. We have the fluorinated polymers. We have many different lists that we can work from. And I just added this paper in yesterday because it's a good representation of that. This is not a typo. This came out on the 5th of April, which was yesterday. And so this is just another opportunity for how we can divide up this class of PFAS. And they've provided the opportunity to do that based on structure. And so you can divide by structure, you can divide by function, you can divide it in many different ways. And this just shows how fast that space is moving. And I think the take home from this needs to be that your definition of grouping needs to be appropriate for the decision that's being made. It shouldn't necessarily be one size fits all, that one grouping structure or strategy is appropriate for all different decision-making groups. Me as a consumer may choose the entire group as my group. I don't want anything with PFAS in my home. Good luck with that, but that might be your approach. Whereas a regulator may have a different approach, or a hospital may have a different approach, or DOD's buying authority. So the next real big question is, health and safety are relatively easy to define and more easier to get your head around. Whereas the functioning of society is a very, very gray area. And so this is really just to highlight that essentiality requires jurisdictional context and judgment. And so that's going to be very different in, for perhaps an environmental agency in the middle of Africa that's working at a very different level than, REACH in Europe or state and federal regulatory agencies in the US. And what functioning of society means is going to be very specific for that jurisdiction. And so I put this in here to say that there is flexibility in that definition based on who the decision maker is and what question they're asking in that definition line of the framework. Knowledge of the technical performance is required. This is actually a really big challenge because we don't know, where PFAS are in all of our products. And in many cases, manufacturers don't. We just heard about the Keen example where they had to track down where PFASs were in all of their manufactured shoes and other goods. And so there's going to be a definite need to work with industry and with manufacturers in order to identify all of those places that could potentially be thought of as essential within the products where they're being placed. And then to go along with that, it's then identifying what that technical performance is within that particular use case in that process or product. And this is where, in many cases, when we get into some of the more technical industrial applications, that it is in many cases only those experts from within that industry that will know whether or not it is truly essential or not. And so by opening that sort of little bit of a black box of the CBI and the way in which we don't have visibility into that now, by partnering better and getting that visibility, it will also spark more innovation, because now we've defined an opportunity to remove that if a substitutable product could be found. And that's part of the whole framework for alternatives assessment. Okay, and so I've just put in here the chemical end use and service function, and in that Tickner et al. Paper, they also go into that quite well. So if you'd like any additional information on that, that's a great resource. And so additional challenges, PFAS, as you all know, are high, are in many, many products and have incredible volumes in some of those applications. And so that's going to take a really thoughtful and phased approach. There is no, let's just pass a no PFAS regulation, and to think that that would then be implementable in a very short time is really not feasible or realistic. I think the approach is, and the essentiality concept is applicable because it allows some of those non-essential uses to be phased out earlier, and some of those essential uses to continue for some period of time. Going late on the second day allows me to sort of reflect to a lot of the other talks that have been given. And there was one by Dr. Andrews yesterday that really the question that was posed at the end of his talk was, if we had this to do over, what should we do different about the way we approach PFAS? And he said, and I agree, that we're kind of in, at least in the US, in a very catch-up mode, where the problem is already there. The problem is already trying to be addressed after it's been established, and taking a more precautionary approach and justifying exceptions to allow use, as opposed to trying to track down chemical by chemical, saying that we should not be using these if we want to be protective of public health, is sort of, flipping that coin would be very beneficial if we could have done that from the start, particularly because of the persistence of this chemical or a group of chemicals. And I would agree, and the essentiality concept really supports that, because by making it you have to apply for exemption based on your claim that this is essential, will then allow the opportunity for industry to know where these are essential and be able to develop those new approaches to be able to design engineering or other types of fixes to be able to now include that in a phase out. The last couple challenges I wanted to talk about are multi-component consumer products. I mentioned the cell phone, where there are many different applications, but think about the fire truck or the ambulance. Absolutely, there are applications for PFAS in that are going to be clearly necessary for health and safety and the functioning of society. But each application within that product really needs to be evaluated individually, because the one that allows perhaps some of the medical tubing in the back of an ambulance may clearly pass that bar, whereas the Scotch guard in the driver's seat may not. And so making sure that we're looking at each particular use case is very important. This is the slide that I'm including, just so that once you have it, you can get the references for some of the work that I've talked about here. This is not an advertisement for ES&T or any other journal. And in fact, after serving as the branch chief for EHP, I'm actually a little embarrassed by this. And then I'll close just by maybe taking a little bit of a different view as well, and saying what's not essential, because that comes up as well. Luxury, convenience, and decoration, they're not essential. And performance above the bar. And what I mean by that is, although, and we saw Ray had a talk, and Washington, I guess, has a regulation now for food packaging that says, does not perform considerably less than the currently available. And I would suggest that that may not be the right approach to take, because I think about my cookie wrapper, and they grab my cookie and they put it in there, and I use that for about 30 seconds. And the current cookie wrapper might be able to protect you from the grease of that cookie for a month. Do I need it to perform at that level? Or what is the actual bar to provide that technical function that's really needed? So maybe not equal to what's currently available, but rather fit for purpose and appropriate for the use case that you're evaluating. As we said, economics and feasibility are to be considered, but only in the substitution range. They are not considerations for the essential function itself. Whether it's an essential function shouldn't take into account cost, those sorts of things. That's independent. Poor skills are not considered essentiality, and that's the example of the Teflon pan in which you cook your egg. My wife can cook in stainless steel and make eggs just fine, and I have trouble with that. And so that should not make something essential. And then product differentiation in marketing. And we saw that in the ski wax talk earlier today, where things are being advertised as full fluoro because there's a perception that it's better in some use cases. And that does not then make it essential for bottom line, or it may be essential for your bottom line, but that does not make it essential for a use case. And then I'll close just by again saying that the chemical cannot be deemed essential. Only the specific use case can. And so there shouldn't be an evaluation of, because oxygen might be essential for life, but in the situation where it's in fact rusting, that is not an essential process for life. And so, hemoglobin, great, but my 52 Chevy, not so great. So let's think about where the chemicals are acting, not necessarily just the chemical globally. And very, very much thank NUMOA and their partners, as well as the Public Health Service and NIEHS and the Global PFAS Science Panel.
On the last liner.
Do you dance, Ron?
You are essential.
You're gonna have to,
In what use case?
you're gonna have to do a soft shoe out the door. Okay, I think we've all recognized who the last speaker is, Mark Rossi, Executive Director of Clean Production Action. He's been part of the CPA team since 2004. He's the founder of Biz NGO, collaboration of businesses, advocacy organizations, and government agencies who work together to advance safer chemicals and sustainable materials. He's the co-founder of Green Screen for Safer Chemicals, globally recognized chemical hazard assessment tool that governments, businesses, and NGOs use to identify chemicals of high concern to human health and the environment, as well as safer chemicals. And since becoming executive director in 2015, Mark led the launch of Green Screen Certified, a certification program for products that avoid chemicals of high concern and use safer chemicals, and the integration of the Investor Environmental Health Network into clean production action. Welcome, Mark.
Thank you, John, and thank you for all of you for still being here with us. I don't know what I did to Terry and Andy to get the honor of being the last person to present, but it wasn't good. So I am pivoting to. I know you're still here. What a dedicated crowd.
There are two other tracks that have a session like this.
Okay. I'm part of I have a community. So I'm here to focus on alternatives to PFAS and the framework that we've been using to do that work. So just briefly, Clean Production Action is a nonprofit organization. We're 20 years old, and our focus has been on identifying safer solutions to toxic chemicals. And we do that through collaborations and tools. And John highlighted those programs. So we have BizNGO and Investor Environmental Health Network, which are collaborations. And we have two tools, the Chemical Footprint Project and Green Screen. And today I'll be going through a deep dive into our Green Screen certification program. So, and there's a euphemistic we here, but there's this emerging demand, and we've heard that today as we're talking about where PFAS is used, that right in general, there's this demand for PFAS-free products, right? But how do we know an alternative product is one, PFAS-free? And I put that in quotes because you're all very aware of this, but right, we have to define what does PFAS-free mean? And we really want it to not be a regrettable substitute. And, ideally we want it to be, well, we really want it to be safest and healthiest and most environmentally preferred, but generally, right, it's a trajectory. So we want it to be safer and more environmentally preferable. So as I walk through, the work that we've been doing at Clean Production Action, and we've been on this journey with many of you in this room and outside of the room, is right, how do you define PFAS free? How do you define what a preferred, safer alternative is? And as Mark highlighted, right, chemical alternatives assessment is a complex issue. And what we've really tried to do with Green Screen Certified is to take a lot of this complexity and simplify it, right? So we're trying to simplify it because purchasers, they want to know, is this a preferred product or not, period. They also want to know the framework that got to making that determination is robust and trustworthy, and they think it's a framework that actually is addressing environmental and human health issues. And then suppliers actually really need, if they're not required to do it by regulation, if it's a voluntary market force, they need an incentive. And their incentive is, if I get my product certified, at least I'm going to maintain sales. Ideally, I'm going to grow sales, right? So there's an incentive. So certification actually creates this incentive for suppliers to, I would say, come clean, to disclose what's in their products. One of the major barriers that we all know to identifying a preferred, safer alternative is, well, what is in the alternative, right? And if suppliers don't have an incentive to provide that, then they're not going to, unless they're required. Just to highlight, some of the Green Screen, we launched Green Screen as a chemical hazard assessment methodology in 2007. We launched certification program in 2017. Just to highlight some of the users of Green Screen, we have state governments have used both the hazard assessment methodology and certification, local, San Francisco, Oregon, Washington State. Julia was just telling me about work in Massachusetts. We have a number of standards and organizations in the building products sector. Google is up there because they've used Green Screen around how do you select interior building products and for screening around in building products. It's been used in the apparel sector, H&M, Levi's, and a standard ZDHC. The electronics sector, Apple, HP, EP, and TCO are standards. And it's been used in the healthcare sector, Kaiser Permanente, and Vizient. And it's an interesting sort of mix of organizations, right? You have sort of institutional purchasers, either at the corporate or at the government level. And then another key player in all this work are these standards, because if you get certifications into the standards, right, again, that incentivizes the suppliers to make these changes. So over the past 5 years, we've launched 5 certifications in 5 different product categories, and we do it different for each product category because, not surprisingly, right, but the chemistry and the materials of each product category differ. So to really understand what would be a preferred chemistry and also what are the chemistry to avoid, we tailor that to the product category. So, and I'll go through how PFAS plays into all these different product categories and some highlights around them. So right now we have 217 products from 19 manufacturers that have certified products. For firefighting foam, we have 15 products from 5 manufacturers, and there's more in the pipeline for firefighting foam. Food service ware, 48 products from 2 manufacturers. Furniture and fabrics, and it's really been fabric manufacturers that the first have been through that process. So we've got 4 products from 2 manufacturers. Cleaners and degreasers in manufacturing. So these are specifically chemistries that are used in the production of manufacturing operations. And this was especially for electronics manufacturing. So we have 8 products from 3 manufacturers. And then textile chemicals are chemicals used in textile manufacturing, not the final product. 142 products from 7 manufacturers. And just to give you a sense, these manufacturers are in Asia, they're in Europe and the US. So it's been adopted and used globally in these different product categories. And you can go to greenscreenchemicals.org and see all the details and a lot of the details that I'm presenting today. So, right, what does PFAS-free mean? So in our product certifications, right, we have to, of course, tackle this issue. And so one is intentionally added. So we don't allow PFAS to be intentionally added to any of the product certifications. And the companies have to disclose what the chemicals are in the products. For furniture and fabrics, there's some it's a little bit trickier. I could get into some of the details if there's questions, but just in general, you can't have intentionally added PFAS added into the product. Like in furniture and fabric, we gave an exception for spray coatings because when we launched the certification, there was not much in the way of alternative in terms of spray coatings. If we start to find that there's a lot of alternatives for PFAS in that application, then we would remove that. But the real challenge in the certification is not around what's intentionally added, right? We say 0. You can't have intentionally added PFAS. And our definition for PFAS is the OECD definition. But it's the impurities, right, that are the really challenging issue. So we set thresholds for all the standards. All the standards, you can't have any PFAS at 100, above 100 parts per million in the product. But then we've set specific testing requirements for firefighting foam, food service ware, and furniture and fabrics, because those are places where we know that PFAS is being used and you have to do product testing. In textile chemicals, we're looking into certifying durable water repellents. And if we do that, then there would be a testing requirement for obvious reasons. Interestingly, in cleaners and degreasers in manufacturing, PFAS are used in some product categories, but again, it's been intentionally added and we don't require any product testing. So here's the fun eye chart, but so we, in terms of evaluating unintentionally added impurities, residuals, non-functional constituents, whatever you want to call it in terms of being present in the product. So we've had to say, okay, so you have the firefighting foam, furniture and fabric, and food service ware. We have to specify what is the measurement method, right? So in some, for firefighting foam, it's total organic fluorine. For the other two, it's total fluorine. And then what's that threshold to pass? And right now, like this, both like what's your measurement method and what's your threshold to pass, right, is hotly discussed issues. I know like state governments are looking to ban some of these chemistries. So what's that threshold get set at? So we, like in firefighting foam, to use that as an example, when we launched that certification, we had to be out there to say, okay, what is going to be that threshold? You know, they had to find, of course, the laboratories that do that work, the different test methods. Earlier today, you know, one of the speakers highlighted the challenges of testing for PFAS in fire foam because of the different matrix, right? So whatever your material matrix is, the appropriate test method is going to vary. And then you've got these, you know, minimum detection limits and analytical labs that can do this work. And so, as we know, this is a really hotly evolving field. And the way that we look at this is we're trying to either align to current practice in the field. So when we set food service ware at 100 ppm, that aligned with what Biodegradable Products Institute was doing, and other frameworks were looking at 100 ppm. You know, Denmark is using 20 ppm. So there's this question of like, do you lower the threshold there? So this is going to be a field, and as we know, it's going to, those thresholds and the detection limits and the testing methods are all going to get more refined, and they're going to get more exacting. But so every time we go through this process, we go through it with a technical group of independent scientists, advocacy organizations, the manufacturers, and the purchasers are all providing input, you know, as we create these standards. So just to use the example of green screen certified products for firefighting foam, I mentioned we have 15 products. So we are certifying for Class A and B foam concentrates, as well as wetting agents that can be used for Class A and B firefighting fires. And so you can go on to the website and check out like the companies, the products. We also added in over there on the right side, more detailed information. This clicker doesn't really show up, does it? Over there on the far right are notes about what standards that they meet. One thing that we don't do is we don't evaluate performance. That is not our expertise. There's a lot of other organizations out there in the world with the expertise around performance on any product category. So our role is that we take on is evaluating the chemistry of the product. And we get all these companies provide us with complete chemical ingredient information. They have to provide us with information around impurities above 100 ppm. And we also, when we look at the chemical ingredients that are put into the product, we're also looking at what are the likely impurities that are associated with that chemical, and we'll follow up with the companies with questions around impurities. And then they have to test, do the test method for PFAS to validate that they are below those thresholds. But we don't do the performance, right? Other organizations that would know that information, we leave that in their world to understand whether it performs. So we can say it meets these criteria for health and safety, then it's on to you to identify whether it meets your performance requirements. So just an example, this is, you know, BioX is one of the companies with certified products, National Foam, Angus Fire. We also, you know, organizations, Michigan and Wisconsin, for example, reference green screen certified as a place to find fluorine-free foams. You know, when we set that standard, and pretty much to this day, you know, what you would define as a fluorine-free foam was defined by green screen. Like we were one of the first out there to define that as a standard. ALS, the laboratory, highlights that they do green screen certified testing for firefighting foam. So as we know, right, it's all part of this ecosystem. We all have to be part of this ecosystem to create the change. And what we're trying to do is say, okay, here's the certified products, right? And then it becomes critical that purchasers are saying, oh, yes, we want these certified products because we know it's been tested to meet this standard. And we also know that somebody's been evaluating the complete chemistry of the product. So just at a high level, standard elements that are part of any certification are, right, chemical inventory is disclosed under confidentiality. I've always just been impressed that these companies are sharing their full chemical ingredient information with Clean Production Action, a nonprofit organization. I mean, we sign, of course, non-disclosure agreements, but they do provide us with confidential business information. Surprisingly, they'll send it to us by email. We're like, no, don't. We delete that. Like, put it, we have like a confidential file system for you. The product has to meet all restricted substance list requirements. I'll say a little bit more about them. All chemicals are assessed for hazard using green screening tools, and I can provide more of that. And I've mentioned some of the analytical testing requirements. There's also more robust analytical testing requirements depending on levels and certification. So for example, in firefighting foam, they have to meet specific ecotox requirements for testing the product. Because, right, if it gets in the environment and gets into water, we're really concerned about killing aquatic organisms. So this is an example just from the food service ware. So this is the restricted substance list beyond PFAS. And just to give you a sense of the comprehensiveness that we're saying, you can't have any of these chemicals. And it's just so you know, so like when we put bisphenols down here, we specify what are the bisphenols, because manufacturers need to know when we say bisphenols, what do we mean by that? What chemicals are on that? So when we have these classes, like with PFAS, we use the OECD reference list of chemicals. You know, alkylphenols and alkylphenol ethoxylates will provide the list. Organohalogens, we don't provide the list, right? If you've got chlorine and a carbon, right, you know, et cetera, then, right, you go like, okay, we know it's an organohalogen. But for all these others, we specifically specify what are captured in those classes. And this is very comprehensive for food service ware because, right, this is products that we're eating off of. So we're very holistic in food service ware. So then an important piece to know about Green Screen Certified is we've structured it to create a stepwise process to really help move manufacturers along this process. So in many cases, like when we started with firefighting foam and started talking to companies, they're like, Clean Production Action, green screen, what is this? Why would I do this? You know, like there's this whole socialization process that you have to go through with companies about like, oh, that they should be disclosing their full chemical ingredient information and then getting the product certified. So we've created a set of tiered processes, levels across the certification that get to more rigorous evaluations of chemistries and holding the chemistries to healthier levels of standards. We don't have time to get into this by today, but always happy to provide more detail. But in general, the bronze level is it's a restricted substance list that you have to meet, like what I was just showing before around food service ware. At silver, we have something called Green Screen List Translator, which is a list of known bad actor chemicals, which is 2,000 plus chemicals, not including classes. And then at gold and platinum, you have to evaluate every single chemical using the green screen hazard assessment method. But as you get more rigorous, it gets more costly, more time intensive, both in terms of money that companies have to do, just in terms of internal staff time, and hiring consultants to do some of these evaluations. So that's why we have this tiered structure. We do have one platinum product in the food service ware category. And we've got, of course, a lot of silver and bronze categories. And our idea too is that as you get more adoptions in the marketplace, you'll get more competition. And ideally, like for example, at firefighting foam, all the companies are at silver. I mean, they should be wanting to get to gold, but you need some more competition in the marketplace for them to make that one level of investment. Just to close on some of the challenges, one thing around PFAS, and this, all of you will know this very well, but there is lack of standardized test methods, right? There's not like the UL test method for how you evaluate PFAS in firefighting foam. As we know very well, we've heard about relevant test methods vary depending on the material matrix. And also, right, it's a quickly evolving field. On alternatives, it's really interesting. So what we've been finding in like the food serviceware category, companies are eliminating PFAS. They're getting an alternative product. They don't know what's in it. The supplier won't tell them what the alternative chemistry to PFAS is. I mean, that company gets the SDS sheet, but that doesn't tell us much. In some cases, suppliers will provide it to us under confidentiality and not to their customer. In other cases, they won't. But this becomes, a barrier to products getting certified. And my closing point here is just like the manufacturers have to hear, right, a clear, consistent, loud, repetitive demand for this, right, for evaluating the products. Because otherwise, why do it? You can just say, my product is PFAS-free. Right, that's much easier than having to go through a rigorous certification process that requires all these hoops to get through to make that type of claim. So certification, and this has been our journey, is just a much more rigorous level to getting to understanding the chemistry and whether it's safer. And I would say, ideally, right, that these chemistries would be disclosed publicly to everybody, not just to third parties and held behind closed doors, because that's where we want to go, is to, right, full chemical ingredient transparency. But our framework currently provides a stepping stone to a better place. And with that, thank you, and look forward to taking questions. If you have any questions for me, you can reach me at mark@cleanproduction.org.
Come down on the podium for questions. And I'm gonna
Pass the mic.
I'm going to use moderator's prerogative and ask the first question. Mark, I noticed that the list there of the foams that have been certified, they all had an expiration date. So what happens when that date is reached?
Thanks, John, for that question. So the certification is good for a period of time. We set them up for roughly 5 years from the time we launched the certification. So after it takes around 18 months to develop a new certification. So after 3.5 years, we will start to create a new certification because, right, as we know, like the science is constantly evolving. We want to update the certification to the latest and the most rigorous requirements. Along the way, we can make changes within a certification, and we will do that on an as-need basis. But this is an overall. What happens at that period is there's an overall renewal of the standard, rewriting of the standard itself based on the latest scientific information.
Thank you. So I have a two-part question because I work with PFAS both on the product side and the environmental side. So the first question is, what is the basis of the 100 ppm threshold or 1 ppm threshold? Is it any kind of a risk-based threshold or something else, like what's practical? And the reason I'm asking that question is because with these certifications, it seems to me that we're saying it's okay to use the products with that 100 ppm threshold or whatever. But once a product is done being used and it goes to a landfill or something, and then those environmental thresholds are on the order of parts per trillion, which is 1 million times lower than parts per million, then even a little bit of leaching from a certified product could lead to PFAS and leachate from the landfill that exceeds, drinking water thresholds or whatever. So I would like to, if you could speak to that sort of life cycle aspect and where do we go from 100 ppm is okay in products to something that's on the parts per trillion level in groundwater or drinking water?
Yeah, so these thresholds that are getting set are I mean, a mixture of, I mean, they've been really heavily dependent on what you can do with the test methods currently and the detection levels in these different matrices. So that's, and we're also looking at the whole class, right? So we're saying, right, no PFAS. So we want to know, that's why it's either total organic fluorine or total fluorine, right? So we're taking a much big, we want to make sure we're capturing the whole class. And so those test methods, right, having gone down to those PPT and PPB for like you have with the analytes. So there's a practicality issue. It's an interesting point around like, then when you think about it being in a landfill and then it, it leaching out, because I was talking with a colleague today around, like, well, with firefighting foam, it's not like people are drinking firefighting foam, right? So how much is then, leaching out from the product? I would say, right, so and again, this is chemistry that is unintentionally present. And so what we're trying to do, getting that unintentional out is, right, this whole cleaning up of the supply chains, right? And so it's all like this work that we're talking about here is like, well, where is it being used? Then where can you get, potential, exposure into that product? And then, what can you do to eliminate that residual exposure? So I would just say, like, the more that we know, because the solution to me is in testing. We're trying to test to make sure, right, you don't have any of these unintentionally high levels in the product, right, and holding the manufacturers true to that, right, that they're not getting that level. But really, the upstream solution is you were getting it out of all these different places, so you don't have any of this unintentional chemistry there in the first place. Because we're not again, you're going to set these testing levels to thresholds that try and move the market to a better place, right? And to me, it's not static, right? It's a dynamic environment, and you're going to constantly be making those requirements more and more stringent as you learn that information over time. And a lot of you are knowledgeable in the audience, so if you want to answer the questions, feel free to.
Thanks. So this is actually a question going back to the essentiality framework, and more a question about the last slide you showed with like what non-essential uses are. So I think essentiality is a really great concept, but I wonder what happens when we get into, even within a jurisdiction, people with different needs. And I guess as an example, right, we had a lot of plastic straw bans that went into effect around the US. And one of the pieces of feedback that I heard from some people who identify as disability rights activists is that people with different physical needs sometimes need the plastic straws. So if we just outright ban them, then, you're taking that essential thing away from someone. So yeah, if you can just
sure.
speak to your
And that really does go back to the jurisdictional question. But even in your example, I would suggest that think about the service that the straw is providing. Well, it's a delivery system for the liquid. And so if what you're thinking about is an essentiality question of the plastic, is the plastic actually necessary for the service? And I would suggest that, in many places, we now see stainless steel straws. We now see other types of delivery devices to get past that service without using the, in this case, plastic of concern. And so, I think your question goes a little bit deeper than that. For that example, that would be my answer, but also that there are situations that there are special needs situations where it might be essential in a specific application like nursing home or like hospitals where you have a higher prevalence of individuals who would need that level of service, where your average or typical use case situation of a fast food restaurant or, you know, something like that may not pass the bar. Obviously, that's all judgment based. And so, you know, I don't want to speak to that particular case in any application, but that's the type of consideration that should go into the framework.
Sorry, I just had to leave my ivory tower. So, but I think, I think we always have these discussions of who makes the decision and what jurisdiction. But I think the key part is right now, a lot of those decisions are being made for us by manufacturers or industry, and we actually have no voice. And I think that's the difference, that it pulls it back to a level where society can at least debate or some other stakeholders have a say. And that will always be better than just having no choice, because right now you just don't know what you get in your product. And now I go back in my tower.
Yeah, another essential use question. Beyond the general philosophy of don't use it unless you have to and only when the function requires it, what kinds of chemicals or classes of chemicals would you apply that to? Because it's not an easy process, just the ones that challenge our planetary existence, or all SVHCs, or what?
Yes. I mean, I think when we first came up with this idea and discussed it, I thought it would be a great framework for plastics. And then after 2 minutes thinking about it, I thought, wow, this is really complicated. But I mean, I think it still helps you figure out if what you could, but certainly flame retardants might be an obvious one. And clearly one of the solutions that you often you just don't need chemicals. You can provide other means, or you actually don't need the protection at all. So really, I think for almost any chemical that has hazardous properties, you would use it. And then I guess that includes polymers these days.
Yeah, I would agree with that, but I'd also add, it depends on who the person considering it. For material scientists, I would suggest that they're doing it for every chemical that's going into a new product that's being designed, because you can eliminate cost. And if you can bring costs down, you can be more competitive in the market space. And so, you know, remember that this isn't, you know, a chemical of concern can be anything that that individual or person within that jurisdiction is looking at. And so in their case, it may be every single component of a consumer product in order to make sure that we're not over designing something that we could deliver that service or achieve that market share without the added expense.
Just another question on the essential use piece. I saw, I think it was in Chemical Watch, I'm looking at the story that reported that about a week or two ago, proposed ban on PFAS in the European Union will unfortunately not incorporate the essential use concept because of timing challenges. And I wonder if you can maybe, I don't know if either of you can speak to that in terms of what's going on about the prospects of the essential use concept being incorporated into EU chemical policy. And it seems to be a significant setback as far as I can tell. And I'm just curious if either of you can comment on that. I don't know if you've been following the debate. Easy question.
It actually is an easy question for me. I can't comment on that. We're a non-regulatory agency, and certainly, you know, we provide some thought and theory out there, the NIEHS and NTP. But you know, that's really going to be them figuring out what's best for them, and whether it's written into regulation or not, or whether it's applied in a more situational approach. You know, who knows where this is going to end up at the end of the day.
Well, my question is really easy. Marcus, do you know? My question is for Mark.
Do you know how to cook your own eggs? That's it. But I do have a question for Reiner. And if we can figure out how to, I'm sure you can. If we can figure out how to restrict PFAS in products, and it sounds like the whole mess of PFAS, or at least the ones you can identify, why can't we manage PFAS as a class?
How about we discuss this afterwards?
I had a question for Mark. You said you do not evaluate performance of the products, but do you contract like a third party to do that evaluation? And then have you ever put your stamp on a product and then discovered it doesn't work very well?
So let's see. So we don't contract out others to evaluate performance. So putting the stamp on a product that doesn't perform as well, that's one where, where we say our focus and our expertise is on doing this hazard assessment chemistry. And that's a gap in the marketplace. Typically you have standards, companies making the purchases are evaluating the products. So you have others that are doing this evaluation of performance. So in terms of the ecosystem of the marketplace, the gap and the largest gap is in hazard assessment of the chemistry of the product. And that's something that Clean Production Action can do. We don't do the performance. And so one of these issues, as you get into implementation of around standards, is how robust and holistic do you go? Because the more you do, the more costly it is, well, A, to create it, and B, to implement it. So so it's always this balance of not letting the perfect be the enemy of the good, to be able to do something more, but not to do everything, right? So there's multi-attribute product certifications, and we don't do that, right? We don't do the whole life cycle perspective of certifications. We would partner with others that do that, and Green Screen has been embedded into others' evaluations of that. So we see us providing this niche that's missing in the ecosystem. And that's why we don't go into that space around product performance, because that's not our expertise.
Hi. I'm not sure who this is going to be for, and I really appreciate the discussion and the topic. I'm involved in the remedial field and often accused of coming from an ivory tower also, though we do get out and talk to residents and people who've been really affected by contaminated water and everything. So I get the perfect balance, I think, between residing in the ivory tower and getting to venture out when I feel I need to. But I wonder, I was kind of reminded by the old television advertisement of the Native American holding up the litter and saying, oh, go out and pick up litter. Now that all the manufacturers have, created this stuff and strewn it all over the place. And I'm wondering if the discussion around essential use may be a little extreme, and perhaps more on, and more of an emphasis on product stewardship or responsibility in manufacturing. And I understand that probably the regulatory infrastructure isn't available to a lot of to push that. So maybe the certification is the right way to go. But Mark, when you use the example of the bike spray, it hit close to my heart because I do a lot of bike riding. And I also found a cable, a bike cable from about 25 years ago, and prominently displayed on this thing was Teflon coated brake. They don't advertise that fact anymore, but it's still all Teflon coated. So as a consumer of that cable, I don't think that I'm responsible for any groundwater contamination. When I throw that cable out, it's going to go somewhere and probably not leach. But the company that made that cable probably polluted, tens of thousands of people's water. So now that I've gone through all the backstory, how do we get the manufacturers to just produce these very, maybe not essential, but these very important, convenient, and in the end, not so detrimental consumer products more responsibly? And you don't have to answer that today.
Yeah, I was going to say, if I had an answer for that, this conference probably would have been 45 minutes and we could have just all headed over, had a pint. But I guess in thinking about your question, what it brings up, and maybe I should have made more prominent in my talk, is determining something as essential or non-essential doesn't mean you should keep it or not keep it. Doesn't mean it's all good or all bad. All it is saying it's essential for health, safety, or the functioning of society, which, in the case of your bike cable, we know that it's not. We know that there are alternatives out there. How do we revert to some of those and provide the competitive advantage in the marketplace? That's really going to be the driver in the US. If we're relying on federal government regulation to get into that space of where that provides that the less hazardous option, we're probably not going to get there. Just realistically, some states are making movement forward, but it really has to be a consumer based, and we have to get past the my one bike cable. How much pollution is that really making? We have to get past that mindset if what you want to do is take hundreds of thousands of bike cables off the market, because it'll drive that company to innovate to something less hazardous and probably become more competitive in the market space. It's just there's no driver for that if, in fact, chemicals of concern are not evaluated in some way to be thoughtfully considered and or replaced using some sort of robust framework.
I just want to add, you've got these different strategies, and so Maine has a strategy, right? By 2030, all uses of PFAS are essentially presumptively banned unless you can demonstrate that, and they didn't use the essential use language, I forget what it is, unavoidable. And so then companies are going to have to make that case. But that's an example of you've got 8 years to eliminate this chemistry. So that's where government can get out and said, you've got this timeline to eliminate this chemistry. So that's really important, especially for these essential use categories where you need that time to innovate, but also having that point in time where it's going to be banned can drive innovation. The marketplace is good in terms of it can advance much more preferable alternatives, safer alternatives. But the challenge is when you have the dinosaurs and the laggards, and if there isn't a regulation, they're not going to move. And oftentimes then they can say, you've got this really good performance and it's lower cost because it's an entrenched technology, and you've already got the economies of scale and usage over time, which makes it a lower cost option. So government is essential for setting that bar, moving the floor up, constantly moving the floor up, setting those signals that they're going to do it helps to create that level of innovation. Because if the federal government passed the Maine legislation, that is significant. That sets a much stronger bar to moving it. So I think it's this combination of factors, right? You're going to need government action. You need advocacy organizations to be driving the government to do it. And as consumers, of course, we can drive this innovation faster.
So I wanted to amplify a little this concept of essentiality and what is essential that goes with it, and to sort of follow up on what Mark and you just said. It seems to me the public's right to know what these products are. And that really is full disclosure. And I mean public disclosure, not just disclosure to, under NDAs, but full public disclosure. And between now and when Maine implements those bans, they're mandating, you want to sell a product in Maine that contains PFAS, you need to publicly disclose that information. And that seems to me to sort of, it should be essential to this essentiality agreement that either we have mandated public product labeling and or product notification. And we have a lot of experience now in this field of mandating that companies disclose what's in their products, or at least what certain chemicals of concern are in those products. There's Mark and I, I'm not even going to ask you to comment on this, Mark. We worked for 2 years on some principles around this, but it just seems to me to be part of this. And it also seems to me that if under the framework that you guys, are talking about in terms of essentiality, something is deemed essential and deemed necessary, or whatever the language is that you choose, the terminology you choose, it seems to me there are conditions that go with that, which gets to this question of what happens at end of life to these products. Do we allow them into commerce with no conditions whatsoever, that they be properly collected and managed to meet whatever, that they don't go into landfills, or maybe they're not incinerated, they have to, or are we going to allow recycling? I mean, you have to give forethought to that. And it has to be deliberative. So just some commentary on this, or some of our experience in other areas.
I don't know if there was actually a full question there, but the one thing I'll also say is that, we've heard a number of questions, and really Mark is probably in a great position to say, the labeling becomes very difficult between PFAS-free and what is PFAS-free, and you've made your definition of it. But how do you then do that at a regulatory level in a way that labeling is informative to a constituency? That's a real challenge.
It's to label that it has PFAS in it. Okay, and you come up with some consistent language around that. And we have lots of experience doing that. Mercury is a good example. Mandated 20 years ago, products sold in certain states, and that ended up being national, had to say that they contain mercury. We then explain why that's important, what mercury is, what it does, so it's not the free language, it's this contains this chemical. That creates a huge incentive for those companies to begin to phase it out, because they're declaring to the world this contains this, substance of concern.
Right. And I guess what my point was even if it's not an added PFAS, the product contains PFAS. And and that, how is that then balanced at what level? If our detection level gets down to, parts per, 1 part per trillion, do we then still require that organization to label in that way? Yeah, but that's,
when it's not intentionally added.
yeah, but that's certainly,
At least what's intentionally used, and we can debate, because that's what Maine is regulating. They're regulating the intentional use and not non-functional ingredients. Again, whatever.
yeah, secondary, raw material sources, those sorts of things.
Any other questions, comments? Discussion or a few comments? Okay, I just want to thank the speakers.